I hope you guys are okay this morning and you enjoyed the previous two presentations. So my presentation is about tabular foundational model. So hopefully, if this term is unknown to you, hopefully, and if I do a good job in the next 15 minutes, you will have a better understanding of tabular foundational model. First, I'd like to just quick introduction about myself. So I'm head of applied AI of Fundamental. I will talk about Fundamental at the very end of this presentation. And I kind of think of my job as bridging the gap, between the science parts and the enterprise application. And I can also recognize that it's a very dry introduction. And as I was walking down through the room today, I've seen like many folks, checking their phone and multitasking on their computer. So we are living in a world where we are competing for people's attention. So my team asked me to introduce a fun fact about me to lighten the beginning of the presentation. And so one fun fact, this image kind of is a summary of my life. So a fun fact is I live in 6 different countries. I think you can see about my French accent. So I'm born in France, studied in Switzerland, I lived in New York, Dubai, Hong Kong, Singapore. I'm actually currently based out of Singapore. And as part of the job, I'm relocating to San Francisco. And actually, I do not live in Korea, but I have some tie with Korea. I proposed to my Korean girlfriend later last year. So I do have tie with Korea. And by the way, I told her, as part of the job, I'm traveling a lot, so she's currently waiting for me in Singapore. She did not believe me that I would put a photo of us to this presentation. So if you guys can take picture just to prove that I did not lie to her, and you can send me the picture after, it would be great. All right, so how to now talk a little bit about tabular foundational model, and I want to maybe do a parallel and share with you my personal story. So I entered the job market in 2011. Yes. In 2011, so you can kind of infer my age. But if I rewind a little bit, what happened in 2011? Have you guys seen the movie Moneyball, by the way? Yeah. So Moneyball, it's kind of, you can make the argument that Moneyball is the first, data science movie. It's all about, using analytics to select, a baseball player in a more efficient way. And it's the acknowledgement that, if you don't use analytics, people have biased to selection. And so applying science make folks unbiased, more objective, and then create more value. So it kind of related. I really love this movie and obviously Brad Pitt. I was thinking, I think this is something interesting here. And on the same year or the year after, Harvard Business Review released that article called, Data Scientist, the sexiest job of the 21st century. And if you read that article, it says that your mom now doesn't want his son to become a doctor, but in the next century will want to become a data scientist. It was very compelling to me actually when I started. So I was okay. Why don't we look at it? And so this is kind of there is many reasons why I entered data science, but that's one of I think the origin story. But and then also what I found interesting in if you look at 2011, 2012, and I'm sure you guys, for those machine learning, for those people in the room that have done data science and machine learning, I'm sure you heard about scikit-learn or you're using scikit-learn a lot. And the 2011, 2012 area is also the start of scikit-learn. This is the first research paper about scikit-learn. And when I was actually building that screenshot, I realized, there is a lot of a French name behind this research paper. And again, I think it's a credit to the community and also the fact that we have such a strong ecosystem in Paris and we have such great events in Paris. So now, this is 2011, 2012, and then, something happened while I was in Singapore 2 to 3 years ago. 2022, GPT 3.5 kind of rocked the world, and I can see, most of the presentation today are obviously about LLM and agents. And kind of in that year, I was thinking, I I spent the past 15 years of my professional life doing data science, and like you could make the argument that data science skills, some of those are transferable to LLM, but some are not. And so I was thinking, why is my job about to become irrelevant? Shall I stay really focused on machine learning, or should I go kind of back to school and learn all of those stuff? And like I come from more like a finance math background, and I also believe that the profile of folks that are very, very strong in LLM are more from a developer background. So there's a little bit of transfer of skills that I was thinking of. But then I took a step back, and if you look at actually in organization, you could make the argument that most of the information that sits within an organization are actually structured data, right? And what I mean by structured data is I mean like table, Excel spreadsheets, CRM, database, and you could make the argument that also decisions that are made within an organization are actually the business decisions are like binary number, like a bank. I want to review loan applications, probably the most common credit risk use case. You accept or reject someone based on the attribute of his application, and all of those information sits in a table. If an hospital wants to know whether a patient will come back to the hospital within 4 weeks, it's going to look at the lab results, and most of those, some of them are free text, but most of them will be sitting within table. Well, and I think the power of LLM, like the inner power of LLM, it remains a next word predictor. And so LLM are great, are writing email, processing unstructured data, and producing unstructured data, but they are not necessarily extremely great to produce number. And I think, but this is a PDF version of the presentation, but if you look at, we put a small video on the right side of the slide, and it kind of show, when you ask, I think it was last year when you ask, what about 5.8 minus 5.11, like very simple math, and ChatGPT make, silly mistake, right? And I think it's also to the fact that when we tokenize number, the underlying model within the underlying logic within large language model do not really understand, that numerical aspects, right? And so those are the LLM. But if you also look at organization, it's actually a process that is done today already. How to apply AI within structured data? Well, this is called machine learning, and this is something that data scientists do, and I've been doing, every day. When you take a use case, you define, what you want to predict, and for those that have done Kaggle competition in the past, you will know this. You kind of clean the data, you kind of do feature engineering, you try to create like aggregate data to extract the most important signal, and then you apply hyperparameter optimization. And then you do that for any use case. A new use case, if you are like in insurance, you do a fraud claims detection, this is one use case, and then you do a marketing use case, and you kind of restart from the beginning. And I think what's interesting to me is this process has not been disrupted. It's kind of the same, if you think about this, it has been the same for the past 20 years, right? We have a lot of investments and a brain power put into large language model, but in terms of machine learning, folks are still doing the same thing. And why also folks spend so much time here is to make accurate results. And it's not trivial to have a very good predictive model. And you could make the point that, is accuracy ever good enough? Did we reach a plateau where, maybe it's enough. You don't need to spend, you need to spend more time optimizing things. But I don't believe this. I think organizations have a very, in society in general, a very tough problem to solve. And, having better prediction can create dramatic impacts for organizations. So there is always a case to do better if science can help us to do better. And so now that I set the scene, of structured data are very important within an organization. LLM is not probably the most optimal approach. And then, this machine learning has not been disrupted for the past 10 years. I just want to give you like a rough idea of the thinking behind tabular foundational model. And so to do that, let's pick just an example of use case, an extremely simple one that are very easy to understand, which is house price estimation. I think anyone that wanted to purchase, some real estate, especially in expensive place like Paris, kind of was thinking, am I making a good deal here? Am I buying or selling, my property at the right price? And then it's, all about looking at the attributes, the size of the house, the type of house, whether the house have a balcony or not, the location, location, we always say location matters. It's all about location. And so this is a typical, machine learning use case. You have your feature, and then on the right side, you have your target variable, the things that you want to predict. And again, a data scientist will apply different, feature engineering, pre-processing techniques, and train like probably a random forest or an XGBoost to have a model. Well, the point here is, what if you could have a model? What if you could have a model that actually included some prior knowledge? If you think about this, a house pricing use case, it's super common, right? A lot of organizations looked at it in the past. A lot of people spend time on this, right? So what if you could have a model that actually know already that, the zip code, 1101, 11201 is actually Brooklyn, and Brooklyn is very rare, and it's probably a bit more expensive. And, square feet is actually about, the size of the house, and this is already some interesting information to extract. So it's a little bit like the Bayesian view here, but what if you could pre-train, not an LLM, but a tabular foundational model on many, many tables, millions of tables, and kind of learn a prior of how the world looks like, how data are generated. And the idea here is, if you apply that pre-trained model, what if it will actually be more accurate than machine learning equivalents and easier to use? And I had one more slide that I had before, but if you look at some of the research paper, we reach a point now where the answer is yes. Those approaches are actually better. It looks like it's better than machine learning equivalents. So there is kind of a GPT 3.5 moment right now in the tabular space. And one of the key person that actually worked on this is Gael Voroko. I think he presented yesterday at Tabicle. Is open source tabular foundational model from the INRIA lab. But if you look at some of the academic paper recently, it really looks like there is a trend here, and those approaches outperform now traditional machine learning approach. So now, back a little bit what we do at Fundamental. So we are also an organization that aim at bringing that technology to the enterprise world. So we develop our tabular foundational model, and so that's a white paper that has been published from us that will be on our website. And obviously, if you guys are interested, you can reach out to me after the presentation. I also have a lunch and learn at 12 p.m. where I demo explicitly the model. And then there is a lot of paper getting published right now in this area. And so now I'm just going to share a little bit about us, not the company, but more the people. And what you see here is actually employee number 1, 2, 3, 4. So we have, it's actually very interesting because the DNA of this company is actually very European. So Jeremy, the CEO, is Belgium. Gabriel is French. Marta, the chief scientist from DeepMind, she's Spanish. And this is why, by the way, our science team is based out of Barcelona. So I'm flying to Barcelona later today to meet them. And Boaz is based out of Tel Aviv. And we have Gael Voroko as a founding advisor. So again, you might have bumped into Gael Voroko yesterday. He's a co-creator of Tabicle, co-creator of Scikit-learn, chief science officer of Probable, and he's a research director of the INRIA Soda Lab in Paris. I believe one also, just one word about the company. So we went out of stealth about 2 months ago, I think now, or 3 months ago. And we are a unicorn. We raised 255 million US dollar for 1.4 billion valuation. And I think it's also credit to the market thinking, you know, there is a trend here and there is something that it's a new technology that can create value to organizations. And I think the vision here is we believe that, so NEXUS is the name of our tabular foundational model, but I think in general we believe that tabular foundational model has the opportunity to become the prediction engine of enterprise tomorrow. And I will finish actually my presentation to this final thought. This is a friend of mine, also based in Singapore, Dean Wong, that says, you know, what if LLM at the end of the day is the right brain of AI? You know, the right brain is the creative mindset, and the tabular model are the left brain of AI, which is more the reasoning, the mathematical parts of your brain. And you know, sometimes you actually need both sides to solve, you know, those problems. And I believe this is my last slide, and I remove one from my presentation yesterday. If you guys can also take picture of this, he actually did not believe I will quote him on this presentation. Thank you very much. And so there is a little bit also of thinking here. You know, we believe Paris is a great ecosystem, and we are actually looking to hire for having people following us into this journey. So this lady is looking to hire more scientists, and if you want to relocate, you know, to Barcelona, or even the job are remote from Paris. Boaz also is looking to expand his team, and I'm also looking to hire. So if you know people or if you guys are interested, you know, you can reach out to me. You have my name, so you can add me on LinkedIn. And again, I have a lunch and learn session at 12 p.m. where I will share more about actually the model, and then you can ask me questions during the presentation. Thank you very much.